In this video, we're going to take a look at some more examples of writing the standard form for the equation of an ellipse. So example 2, part C here, picking up from where we left off, we have 9x squared minus 54x plus 4y squared minus 8y plus 49 equals 0. Now, in the last video, we didn't have these other terms with this minus 54x or this minus 8y, which means that when we have anything else, any other x's or y's, that means that the center of our ellipse is not going to be at the origin. The good news is, even the problems that we looked at in the last video, the techniques to write the standard form in this video, you can apply to the last video. You just have your h and your k at 0 and 0 respectively. But it's going to be very similar to what we did for circles. So the good news is, if that video on how to write the standard form for the equation of a circle, if that was okay for you, then this one should be pretty okay as well. There's going to be slight variations that aren't going to be too major. So our first step is to subtract the 49 from both sides, and we get 9x squared minus 54x plus 4y squared minus 8y equals negative 49. And so what we want to do is we want to find the vertex of each of these expressions, the 9x squared minus 54x expression and the 4y squared minus 8y expression. So finding the vertex of 9x squared minus 54x, oh, by the way, here's what our graph looks like. So we can compare that to our answer and see if they're the same graph. But 9x squared minus 54x, and we want to find the vertex, so I'm going to have to zoom out a little bit here. Zoom out quite a bit. Holy cow. All right, we got 3 and negative 81. So 3 and negative 81 for our vertex for 9x squared minus 54x. We're going to do the same thing with 4y squared minus 8y, but again, just to keep it in the same consistency of this vertex, instead of doing 4y squared minus 8y, we're going to look at 4x squared minus 8x. Again, you're allowed to do 4y squared minus 8y, but you're going to have to remember to switch your x and y coordinates because when you switch, you also switch your h and your k. So I again advise that you look at 4x squared minus 8x. Plus it's nice because we already have it. We just have to change the coefficients for this one. So probably closer to, 1, negative 4. All right. Now, another key difference between the ellipses and the circles is the ellipses have these coefficients in front of the squared terms, the 9 and the 4. And when we looked at parabolas, that would be your value of a for each of these respectively. So we still have x minus 3 in parentheses squared, but we're going to have to copy down the 9 that's in front. And then we still have y minus 1 in parentheses squared. We're going to have to copy down the 4 in front of that. And then we're going to add in the absolute values of the y coordinates to this negative 49. So we have our negative 49 again, plus the absolute value of negative 81, plus the absolute value of negative 4. Or you just drop the negative signs and you don't have to do absolute value. But in any event, when we simplify the right-hand side, we get 36. So we have 9 times x minus 3 in parentheses squared, plus 4 times y minus 1 in parentheses squared equals 36. And we want to get this thing equal to 1, so we're going to divide both sides by 36. And when we do that, we have 9 times x minus 3 in parentheses squared over 36, plus 4 times y minus 1 in parentheses squared over 36 equals 1. And we can simplify the 9 over 36 and the 4 over 36 to get our standard form as x minus 3 in parentheses squared over 4 plus y minus 1 in parentheses squared over 9 equals 1. And let's just check to make sure we didn't make any calculation errors, because if we type that into our calculator here, so x minus 3 in parentheses squared over 4 plus, and I might have mistyped that. No, I didn't. Y minus 1 over. Okay. Y minus 1 in parentheses squared over 9 equals 1. Whoop. And let's see if that matches our original graph. Oh, they're the same color. Of course they are. There we go. Oh, good. So it's the exact same graph. which means that we wrote it properly. So now if we were asked originally to also find the center of vertices and foci, we could now work with this equation like we did in the previous examples. All right, part D, we have x squared plus 6x plus 9y squared plus 18y plus 9 equals 0. We're going to get the 9 over there by subtracting it. So we have x squared plus 6x and then plus 9y squared plus 18y equals negative 9. So first let's find the vertex of x squared plus 6x. So I don't need this example anymore. Well, here's what our graph should look like. But let's look at the vertex of x squared plus 6x. And I have to scroll down. And we get a vertex at -3, -9. So the vertex of x squared plus 6x in blue is -3, -9. Again, I'm going to graph 9x squared plus 18x. So 9x squared plus 18x. And again, it makes it nice because all I have to do is adjust the coefficients. And here we get -1, -9. So the vertex of this, if I use x's instead of y's, is -1, -9. Again, if we use the y's, we're going to get -9, -1, but you're going to have to remember that the -1 is your value of k, not the -9, which is why I advise just using x's. All right, so we're going to have x minus a -3 in parentheses squared becomes x plus 3 in parentheses squared. The coefficient for x squared here is 1, so we don't really need to copy it down since it's 1. We get y minus a -1, which is y plus 1 in parentheses squared, and then copy down this coefficient of 9. And then we have -9 plus the absolute value of -9 plus the absolute value of -9, which comes out to just equal 9. So we have x plus 3 in parentheses squared plus 9 times y plus 1 in parentheses squared equals 9. Now we want to get it equal to 1, so we're going to divide everything on both sides by this 9. And when we do that, we can simplify the 9 over 9 as just 1. So our final answer is x plus 3 in parentheses squared over 9 plus y minus 1 in parentheses squared, or y minus 1 in parentheses squared over 1 equals 1. And again, if we graph that, and I'm just going to spare you that for the time being, if we graph it, it should give us this exact same graph as what the original problem was in the first place. So, all right, that about does it for this video. Thanks for watching.